Hello everyone, I am Pranjal and along with my team are going to present data-driven customer segmentation and game recommendation for SFU. We say it from the SFU community for the SFU community. First of all, why this project? SFU initiative. SFU has introduced gaming rooms and board games to increase student engagement and social life. But there is a problem with this. Low participation rates and people feel this that the games are not relevant to them. Importance of regular participation. It helps to strengthen the bond, and we also felt in our cohort that we could develop stronger bonds than what we have now if we have played more games together. Now, validation of our problem. Is this our problem or generic problem? So we used a Google survey form which was circulated among various students of SFU. This was our form. This was the results from the Google survey form. We were amazed to see around 91.4% of 58 responses wanted to play games which are relevant to the games they have previously played. So we have why of the problem. Now move on to how to solve this problem. First, we are going to tell, we are going to recommend games to students that have similar plots to the games they have played previously. We have also discussed this problem with SFU Gaming Society and SFSS Society, like why this problem was there. So they also told that they have games which they have purchased, but students don't play them, and they have invested a lot in those games. So we are also giving them a solution that we will recommend those games which are cost effective and they can plan their budget accordingly. Third, how can the SFU Gaming Society evaluate if a shortlisted game which we are recommending will be a good purchase or not? Now we are now we have why of problem, how of problem. Now we are going to what we have done to solve this problem. First, data science pipeline. It comes with data preparation. We have collected data from crowdsourcing Wikipedia page and Nintendo Switch website. There was a lot of data to be cleaned and pre-processed. Finally, all this data was integrated and we get a combined data set. Finally, EDA was done to analyze the data and then we use different models and evaluate it. And finally, we will present a data product for this. So these were the EDA and insights. We saw that there were like market share of different game developers. We also saw price range versus count and game genres and what genre is really trending these days. High level implementation. For the first problem, we were setting cosine similarity and we were predicting games on the basis of cosine similarity. In the second question, we wanted group of games together and predict similar games with the least price. So we use hierarchical clustering for this. Third, to tell our problem is to tell our game will be successful or not, we use decision tree classifier for this. Finally, validating a solution. We used interlist and interlist similarity measure with accuracy measure for the first question. We used different Silhouette score, Kalinski, Harbaz index, and cophenotypic correlation coefficient for the second problem for hierarchical clustering. And finally, for the classification problem, we use precision recall and F1 score. Finally, coming to data product. So this was our data product. A student can click over here, select a game which he has played previously, submit. Finally, we will recommend 5 games now which he can play. Society can go on this functionality. They can tell which game they wanted to know they can tell which game they wanted to purchase on the basis of previous games people are playing. Click on this. So our recommended game is this and price of this game is this. So we have recommended this game. So these are the functionalities of our system. So finally, the conclusion. We wanted to work more on our solution, improvise it, make our dataset more specific to SFU, and to implement it in SFU. We expect our solution will help in developing stronger bonds amongst SFU students. Team. So this was our team. Thank you.